Hello, welcome to software testing methodologies. So today we are going to discuss about nice and ugly domains. So nice domains and ugly domains are nothing but good domains and bad domains. So in the domain testing there are some of the good domains which gives the best result and some of the bad domains which gives the more bugs, more complexity will be rises in those ugly domains. So what are those? Now we'll discuss about these nice domains and ugly domains. So first one is nice domain. Nice domains means good domain. How we can say this is a nice domain, this is a good domain. So how we can say means first there are some of the properties which related to domain boundaries. So what are the domain boundaries? What are the properties related to domain boundaries? And those properties should apply on the particular domain. If we apply these properties, then it makes the domain testing is very simple. If it doesn't apply these properties, then it makes domain testing very difficult. So difficulty will be rises in the domain testing when we doesn't apply that properties. So now we'll see what are those properties. So properties of nice domains. If we apply these properties, it is very difficult, and that domain is known as, if the property is satisfied or in but by particular domain, it is known as a nice domain. If it is not satisfied, then it doesn't mean a nice domain. And let's see what are the properties of nice domain. The first one is linear and non-linear boundaries. So you all know that linear is a familiar word and non-linear is also a familiar word. And boundaries, linear and non-linear boundaries. Linear means a sequence which defines from a sequence of instructions or sequence of statements. We'll go for the linear. So nice domain boundaries can be described by using linear inequalities or equations. So inequalities or equalities all can be defined by the nice boundaries can be linearized transformations. So linear boundaries are more frequently used in the used than the non-linear boundaries. So comparing to the non-linear boundaries, linear boundaries gives the best results as it is a nice domain. So we can linearize the non-linear boundaries by using simple transformation. If we perform any transformations on the non-linear boundaries, it will convert it into the linear boundaries. It transformed into the linear boundaries, then it gives the then it is a linearized transformation. And when the testing applies on that linearized transformation, it gives the best result than comparing to the non-linear boundaries. So that is one of the property to be satisfied. So this is one of the first property, and let's go for the second property is nothing but a complete boundary. The name itself tells what is meant by complete boundary. So complete means entire system from starting to the ending. So that is the way to define the complete boundary as one of the property. So nice boundaries have complete boundaries because they cover from plus infinity to the minus infinity, entire from starting to the ending boundaries. If we cover entire boundaries plus infinity to minus infinity, it is known as a complete boundary, and it is one of the property to be satisfied whether it is a nice domain or not. One of the main advantage of this complete boundary is that it requires only set of tests to verify the boundary irrespective of the number of surrounding domains. So complete test should be performed to verify the boundaries. So number of surrounding domains. So that is nothing but one of the property. Second property, complete boundary. Next, third property is nothing but orthogonal boundaries. So orthogonal also is a well-known word for you. So here I am taking that nice two domains, two-dimensional domains. So here I am taking the two-dimensional as A and B. A domain and B domain is the two-dimensional domains, and here A1, A2, A3, A4, A5 are boundary sets. A and B are the two boundary sets, and sets that are orthogonal to each other. A1, B1, A2, B2, or A1 to B2, A2 to B3, A3, B4, whatever it may be. So as two boundaries A and B are orthogonal, then they can be tested independently of one another. So orthogonal boundaries can be tested independently of one another. So in the table, whatever defined in the table, so that table there are 7 boundaries in A and 5 boundaries in B. So total 7 boundaries A, A1, A2, A3, A4, A5, A6, A6. A, A1, A2, A3, A4, A5, A6. and 5 boundaries B, B1, B2, B3, B4. So that is nothing but 7 boundaries plus 5 boundaries is nothing but 12 boundaries. We can denote these boundaries by using a big O notation. It defining by using the big O notation till the above orthogonal boundary. We can do it by testing its intersection points, but this change can change the linear growth. Big O notation of n into the quadratic growth of n square. Why? Because it has two boundary sets. So that is nothing but orthogonal boundaries, and also this property also applied whether to check that domain is a nice domain or not. So next, another property, consistent closure. Closure is nothing but a closure bug is nothing but a when the bug will be defines goes into the wrong path, it is nothing but a domain closure, wrong domain. So consistent closure means if that testing will be done in the right way, that also should be performed the consistency should be performed in that domain testing. Consistent closure, the most simple and fundamental closure that gives a systematic results after performing the required analysis. When we go for the consistent closure, it gives the systematic results. So it doesn't give the inconsistent. It leads to the inconsistent closure whenever the the domain testing applies. If there is any problem rises in the consistency, it leads to the inconsistent closure. So in the below figure, there is a shading lines. I will show that. Boundary shows the domain consists of shading lines. Inconsistent closure is contrast to consistent closure are not fundamental and does not give systematic result. So what I told in the previous line, so inconsistent closure doesn't give the systematic results. So that's why consistent closure is the property to define the nice domain. And see this two-dimensional, this is the x and y, and these are all the connected lines which defines the time dimensions of the predicates. X is equals to a1, a2, a3, a4, these are all the predicates. Y is equals to, this is the equality transformation, y is equals to y1 plus cx, all this. So these are all the consistent closure, so which goes into the right path, there is no wrong path. So this is one of the property to be satisfied whether it is a nice domain. So next property is nothing but convex. So convex, for any two boundaries with two points placed on them or combined by using single line, then it is known as a convex property. Then all the points on that line are within the range. If the points are placed on two boundaries, for any two boundaries, 2 points placed on them are combined by a single line. 2 points are combined by a single line. It is known as a convex property. Then all the points on that line are within the range. The range will not be out of that particular range. It defines the bug. Within the range means it doesn't define bug, and the property will be satisfied, and it is known as a nice domain. And nice domain supports convex property, whereas dirty domains no. And that is one of the property. Next, another property is nothing but simply connected. The name itself is nothing but connected part is also one of the property. And nice domains are simply connected because they are available at one place as a whole, but not dispersed in another domain. Simply connected and convex domains are related to each other. So both are combined, both are connected. So convex and simply connected are the two properties need to be satisfied whether it is a nice domain. And last property is nothing but a systematic boundaries. Name itself. If there is no systematic results, it is not a systematic boundary. So this little systematic boundaries refers to the boundary inequalities associated with simple mathematical functions such as constant. So if there is any simple mathematical functions, those are all constantly defined as a systematic boundaries. Then it is known as a nice domain, and the properties to be satisfied in this way, it is known as a nice domain. If the boundaries are systematic, then generating a test for one boundary can automatically generate a test for remaining boundaries within that particular set. It is known as a systematic boundary. And this property also satisfied, that domain is known as a nice domain. So if all the properties are satisfied, then it is known as a nice domain. Like linear, non-linear boundaries, systematic boundaries, convex, simply connected. So these are also all these properties are applied, and those properties are satisfied on the particular domain. It is known as a nice boundary. nice domain. And so next one we'll go for what is meant by ugly domain and how it satisfies. So what are the ugly domains? So what is meant by ugly domain? I already told you that ugly domain is nothing but a bad domain. It gives more complexity, it gives more bug. And what are the main simplifications over there in the ugly domains? We simplify in this way, then the ugly domain is converted into nice domain. And these specifications can be either good or bad depending upon the specifications. Simplifications can be either good or bad depending upon the specifications what we have taken in the domain. If the domain complexity is important and the programmer's simplification is safe, then it does not cause any bugs. If the domain complexity is important and program simplification is not safe, it results bugs. That's why every simplification should perform the safe simplification. That's why what are the simplifications we will discuss here. So first one is non-linear boundaries. So these boundaries may or not present in simple programming because these boundaries do not provide an information regarding simplification of boundaries if they important. So non-linear boundaries may lead to the bugs. So that's why there is a need to simplification of these non-linear boundaries. So how we will simplify this type of boundaries means by removing these boundaries or by converting that non-linear boundaries into linear boundaries and making it as a nice domain. So that's why we'll go for here ambiguity and contradictions defines one of the non-linear boundaries, leads to the non-linear boundaries. Programs can't be ambiguous, contradictory, whereas specifications be. It leads to the holes, cracks in the input space. So holes will be defined, cracks will be defined. Due to that holes and cracks, the bugs will be raised, and that domain you can say it is a ugly domain. And so see here, that holes is denoted with 0, like whole design. So this is a milding out convex. So how simplification will be done for this type of nonlinear boundaries? So this is a milding out concave. So this is the one type of bug rises, and this by using like this will perform that bugs will define that holes will be converted with the parallel line. In that case, we'll definitely will define that ugly bug into converted into nice domain. Ugly domain converted into nice domain. Once the programmers find out the bugs from nice domain topology, then the testers try to simplify the domain topology by using the following cases. So what type of case is nothing but milding out concatenativities. Bugs are introduced by the programmer, which in turn leads to misdesigning of test cases by the tester. Misdesigning will be performed so that the designing will be performed in the successful manner. Then the simplification will be done on topology. So the another one is nothing but connecting different pieces. So see that diagram, connecting disconnected pieces. Whatever the disconnected pieces we are connected here, so that type of disconnected pieces can be defined in this way. So then it leads to nice domains. It leads to the one of the simplification way in the ugly domains. The tester will connect the disconnected pieces into a single as shown in the figure. So this is one of the simplification and filling the holes to be filled. See here. So this leads to the bugs, and this this is the simplification of topology. Which leads to filling the hole. The testers will fill up the empty holes as shown in the figure to simplify the domain. So that is the simplification. Next, another way is nothing but fixing boundary closure. For every parallel line, there is a rule that allows the closures to follow the same path. For example, if there are two domains and the programmer want to remove the spaces between them, he can apply a rule to make all the boundaries go in the same direction. This is the same direction. This is same direction. This is same direction, and this is the end point. It is a different direction which all the boundary points within the limit range. So this is the consistent way which performs the fixing boundary closure as one of the simplification in ugly domain. So next one is differences between specified domain and implemented domain. So these are all the two differences, mainly two differences. First one is these domains may be incomplete because no path is specified for input vectors. And implemented domains are maybe incomplete because there is a path specified for input vector. In the specified domain, the path should not be specified. In the implementation will be done, so path will also be specified. So that is one of the difference. And specified domains gives inconsistent results, but implemented domains will give consistent results. So this leads to this defines differences between specified and implemented domains. So this about nice and ugly domains. And in the nice domains, the properties need to be satisfied. If the properties, all the properties satisfied, then it is known as that domain goes to the nice domain. And in the ugly domains, all if there is some of the bugs rises or some of the complexity rises, what are the simplifications we need to define? If there is a holes not to be filled, the holes to be filled. If there is a inconsistent way of transformation, then it simplified into the consistent way. This leads to the simplification. Then that ugly domains converted into nice domains, and also properties will be satisfied in the nice domain. Then there is a domain testing which gives the best results of 100%. So this is about nice domains and ugly domain. Hope you guys understand about this nice domains and ugly domain. And so this is about nice domains and ugly domains. So thank you.